All right, so my name is Donnie Prakoso. I'm Principal Developer Advocate at AWS, and prior to AWS, I have a couple of experience in enterprise, telco, banking, and startups as well. And I've been talking about DevOps for years, starting in 2016. And then this actually the culmination of the feedback coming from the developers across ASEAN, because I manage 8 countries in ASEAN, and this is the way I answer them. I have a lot of demos in these sessions. Definitely something that, how many of you want to see slides or demo? How many of you want to see demos? Okay, let's do demos then. So I'll make sure that I will minimize the slides. I only have 30 minutes, so let's get this going. Now, we all seen this kind of the benefits of having DevOps. There's no doubts, right? So we could reduce the deployment frequency from weekly to monthly to hourly to daily. It could also reduce the change lead time, and then also to minimize the change failure rate. It's amazing, right? But I came across these questions every time I deliver a talk on DevOps. If DevOps is really give us benefits, why hasn't everyone already moved to DevOps? So we identified 4 different issues, and they are interconnected one to another. The first one is that there are so many tools out there on the internet. I'm not saying they're not good, they are amazing, but they are just too many tools. The second issue is that because we have so many tools, we need to glue those tools to fit into our workflow. That's the second issue. The third issue is that because there are so many tools, it's getting harder for the team to have a centralized management. Sometimes they don't have this kind of insights on what's happening within all these tools. Now, the fourth issue is that because we need to adopt these tools, these CLIs and all those tools, our libraries or frameworks, they need to understand the best practices. Right? So this is the 4 issues that I identified what's happening across ASEAN developers, why they haven't moved to DevOps. Now, today we're going to discuss about 3 things: infrastructure as code, continuous configuration, and CI/CD. These 3 pillars is something that I believe is going to be a good foundation for any organizations who want to adopt DevOps. This talk originally like 1 hour, so I delivered this at re:Invent in Las Vegas last year, and the workshop lasts for 3 hours. So I tried to compact everything I removed on platform engineering and also observability monitoring. If you want to know more about those 2 remaining pillars, you can catch me up after the session. So the first thing that we need to discuss is infrastructure as code, or now what I love to say this as infrastructure is code, because I want to show you something cool with AWS CDK. Now, the notion behind infrastructure as code is very easy and makes sense. That we need to treat infrastructure the same way we treat codes. Right? So what does it mean? It means 3 things. The first one is that we need to make infrastructure change repeatable and predictable. Right? So whenever we run this script or we run these IAC applications, we want to have a repeatable deployment. The second thing is that we need to release infrastructure changes using the same tools as we use for our code, for our applications. And the third thing is that we need to replicate production environment. Either it's going to be on staging, on the production, or UAT, we need to minimize the differences between these environments. And this is something that I really like. In the past, I believe it was in 2012 or something. Anyone remember about 12-factor apps from Heroku? Right? So that's something that's really cool, because it says a dev prod parity. Because we need to understand the difference, we need to minimize the difference between those environments so we can replicate or reproduce any kind of issues. Now, I always like to start with a simple way to implement IAC. In this case, let's start with simple tasks. Let's build a serverless API gateway. So we have Amazon API gateway, and then we have 2 AWS Lambda functions. And each of the AWS Lambda functions all the logs will be transferred to Amazon CloudWatch logs, and all of them connected to Amazon DynamoDB. Right? So in the past, for those who haven't adopted DevOps, the way that they do this, probably they go to the console, right? They click Amazon API Gateway. They click Amazon DynamoDB first. They create AWS Lambda functions. They create IAM to get the permission to Lambda functions to save into DynamoDB, and then they create Amazon API Gateway. Now, once that we adopt the ISC, I told you we've seen so many tools about ISC. So this is AWS ISC portfolio. We have AWS CDK, we have AWS SAM, we have AWS CloudFormation, and we also love to use Terraform, Pulumi, or even Ansible. Right. So the first question, whenever I talk about DevOps, and developers are going to ask me this thing, which tool should I use? There's so many different options, right? And throughout the years, I realized the most practical answer is that these two. It's your preference. Either you want to adopt the ISC in a declarative way, or do you want to adopt ISC with high-level programming languages? So if you want to adopt ISC in declarative way, you can use Terraform, you can use AWS CloudFormations. Anyone here use Chef, Puppet, Habitat? They are really amazing tools as well. But if you want to use high-level programming languages, you can also use AWS CDK and Pulumi, or even Troposphere. So there's many tools out there, and that depends on your preferences. Now, in my case, I love to adopt the ISC with high-level programming languages. So the simple reason why, because my team, they are more familiar with programming languages instead of the declarative language on these each tools. Right. So that really depends. This is in my case. In your case, probably you have a more diverse competency across your teams and you prefer declarative, that's good. But in most cases, most of the developers, they want to provision the architecture and infrastructure using high-level programming languages. And this is where I need to introduce you to AWS CDK, or Cloud Development Kit. Anyone here has played around with AWS CDK before? Cool. So only a few of you. That means I'm going to show the demo, more dive deep into AWS CDK. So what is AWS CDK? So AWS CDK, in a simple way, is that you can use these frameworks, libraries, and CLI to provision your infrastructure and architecture to connect all of those resources with these programming languages. You can use Python, TypeScript, JavaScript, or even Go. And this reduces the friction for the developers to adopt ISC because they already know these programming languages. They already know how to implement classes and APIs, and they can just simply build an applications, CDK applications to provision the infrastructure and architecture. Now, something that I really like to emphasize is that whenever we adopt ISC, in this case, is that we need to identify the workflow first and the tools after, not the other way around. Now, I want to show you the development workflow, how that you can work with AWS CDK. The first thing that you need to do is that you need to create your stacks and constructs. And you can do that by running CDK init. And then you can build your applications using NPM if you use JavaScript or TypeScript, or you can use pipenv if you use Python. And then you can do CDK syn, which is going to synthesize your applications into Cloud Assembly. And this is something that will be understood by AWS CloudFormation. And finally, that you can deploy your CDK applications into your AWS environments. That easy. Right, so there are a few things that you can do. You can just run CDK syn and then use these AWS CloudFormations and run it manually, or you can just run CDK deploy and it will deploy all these resources into your AWS account automatically. Right? Okay, so it's demo time. So what I want to show you, right, so it's too small. Right. So this is the CDK application for serverless API that I shared with you earlier. It's really simple. We have Amazon API Gateway, we have 2 AWS Lambda functions, and we also have Amazon DynamoDB table. Now, in this case, this is how that I model the DynamoDB. So I define the DynamoDB, I define the read capacity and write capacity. Practically everything that you see on AWS console that you can configure using AWS CDK. And then don't forget about the IAM role, because we need to implement the least privilege. And in this case, I just want to add some role, the IAM role, to write and create the log group in Amazon CloudWatch. And I just want to define specific actions that these Lambda functions can do on DynamoDB. Right? And then this is my Lambda functions. As you can see, everything is configurable here, starting from the timeout, the role, tracing for observability, and also the runtime. I can also add the environment variables. Right. And then we have DynamoDB, we have IAM roles, and we also have Lambda functions. Now, the last thing that we need to do is that we need to create the REST API on Amazon API Gateway. And this is how I define it. I just need to define the construct, and then I need to integrate with my AWS Lambda and add the URI for each my Lambda functions. Right? So next thing that we can do is that we just need to deploy. So what happens in the background is AWS CDK is going to synthesize the CDK applications into CloudFormation templates, and it's going to automatically deploy. And this is the output. As you can see that we have this really nice URL here. And if I just run curl, we can see it works. And this makes it easy and minimize the friction for developers or the operations teams to adopt ISC. And if you go to the CloudFormation, you can see all these resources also available in CloudFormations. And this is the DynamoDB table. It's also being created automatically by CDK application. All right. So the next one, that's the first demo. Oh. Not this one. Okay, so the next question that I received from the developers is that, that's nice, but there's only one application. And you also mentioned about how to maintain the dev prod parity, how to maintain the differences between environments. How can we do that with AWS CDK? Now, this is something that I really like by adopting the high-level programming languages. Now, if we go to the application here, you can see this is the application, the stack of the CDK application. And if I just copy here, and I create like probably stack 2, CDK app, stack prefix, I'm just going to add staging. I just need to add this one. Just save it. And then if I list all the CDK, oops, my bad. If I list now the stacks that I have now in my CDK applications, it will show 2 stacks. Now we have the production and we have staging. And you can reproduce this in any kind of environments. Now, this is the next question that I get from the developers. Hey, Donnie, this is good, this is nice. I love the CDK application, CDK, and I can create the applications, but I use Terraform. And the good news is that you can use CDKTF. So with CDKTF, this is something that you can take your HCL and then you can convert it into CDK applications, or you can also do synthesize from your CDK applications into your Terraform. And it also has a CLI as well. I don't think that I can have time for this demo, but I'm going to show you anyway. So you can just run, so I just want to quickly show you how it looks like. So this is the normal Terraform written in HCL to define AWS Lambda. And this is the CDK-TF application. So as you can see, adopting the ISE in currently, it all boils down on your preferences if you want to use decorative or you want to implement using high-level programming languages. Now, the next thing that we can do here is that you can just run CDK-TF like this, or you can also run CDK-TF apply, which is going to deploy your infrastructures into AWS. And you can also convert using CDK-TF convert from your existing HCL files into CDK applications. It will going to create a CDK application automatically. Right. So like you can see that it's currently synthesizing. There you go. So it makes it really easy for you to implement ISE. Okay, so the biggest pain point for the past few years for developers or the ops team who want to adopt ISE is that I'm pretty late joining this game and how to convert my existing resources into ISE, right? So in the past, what you need to do is that you need to create the CloudFormation again, and then you need to delete it again, and then you need to recreate everything into CDK application. But a couple of weeks ago, AWS just released a really cool tool within the AWS CloudFormation, and it's called ISE Generator. And this is pretty cool. Why? Because with the ISE Generator, if you create your resources outside of CDK or outside of AWS CloudFormations, practically you just create using ClickOps or even API, you can just scan your account, and then you can create a template. You can start from a new template, test, and then you just click next, and you add the resources that you want to create into a CloudFormation template. And this is really cool. Why? Because it minimizes the barrier for us to adopt ISE. And once that you already create a template and add all the resources that you need into your stack, you have it here, and then you can use the template definition as is and put it into AWS CloudFormation, or you can also use AWS CDK. You just need to download the template and then run this command. So CDK just released a new feature called CDK Migrate and CDK Import. So what it does is that if you go to, which one is this? Oh, it's import. If you just download the file on a CloudFormation, and then you just run this command. This one is wrong. ClickOps. No. It's going to create the CDK application based on your CloudFormation template. And it's now with everything now on the CDK, you can do pretty much what I already showed to you. All right, so that is the CDK migrate. There's another issue. CDK migrate is for you to recreate your applications into CDK application. But if I want to use my existing CD applications and add the existing resources that I didn't create using CDK, now you can use a CDK import. And CDK import is something for me is quite magical. Let me show you why. So if I go, so not this one. CDK import. So if I go to CDK import, I just want to show you quickly. This one, I have S3 bucket, right? This S3 bucket, I hasn't defined it in my CDK application. As you can see, this is just S3 bucket I just added this morning. And the next thing that I can do is that I just run CDK import. And why I say it's magical, oh, it's too small. So why I say it's really magical, because CDK will try to identify which resources that I have on my CDK applications that is not listed in my AWS CloudFormation. So this way, CDK has this context. If I want to import the S3 bucket and just enter the bucket name or enter the ARN. Right? And it's going to create automatically the resources for me. So, right, so that's ISE. The other thing that I want to emphasize in this session is that how important the configuration is. Now, if you remember the 12-factor apps, practically it says that we need to decouple the application source code and then the config to have a release artifact. And back then it was mind-blowing for me, because back then in my company, we created various applications for different environments. In fact, the only thing that makes a difference between one application in running in one environment and other environment is only the configuration. So the configuration management is something that I really want to show it to you. And for years, people have been doing environment variables. You can also use .file as well. And something that I want to share with you is that within the system managers, there's a feature called parameter store. So this parameter store is coming very handy. You can retrieve, you can create on the fly, and it can be retrieved by your applications running in anywhere. But what I really want to show to you is app config. Probably you haven't heard about app config before, but to me, this is game-changing. Because with app config, I can easily define the configuration profiles and the feature flags. And I can also define the environments. So here I have staging and production. Now, with these environments, I can easily version all the configuration, and I can also do the validation, right? Now, the validation is really important because up until now, probably we haven't tested the configurations is in the right format or not. In this case, I have debug, right? Debug is the required properties. Now, if we go here, we can say that I don't have any debug properties. And what happens if I start the deployment? Oh, so there's a different deployment strategy. I cannot start the deployment. Why? Because it fails. It doesn't confirm the validation test that I created. And this gives us a guardrails on the configuration management. So our applications can behave properly by using the definition that we want it to be. Right, so that's configuration management. And lastly, let's talk about CI/CD. Most of you know about this. This is the release process stage. We have source, we have build, we have test, we have deployment. We have source, which we're going to get all these codes from our Git repository. We build, we do unit tests, we try to create the release artifact, we test it, and we deploy in our application environments. Continuous integration from source to build, continuous delivery. We have a manual approval before we deploy into a specific application environment, or we can also implement continuous deployment throughout all of our environments. Now, once that you already adopt CDK, it makes it easy for you to create a pipeline by using this library called CDK pipelines. Now, with CDK pipelines, this is actually an L3 construct. This is opinionated construct, but it will help you to define your release pipeline. So let me share with you how that you can implement CI/CD with CDK pipelines. In this case, I'm just going to deploy my serverless API into one environment, and that is staging. So which one is that one? Oh. Okay, so here you go. First, you need to define your CDK application stack. This is the same stack that I used for the first demo. And then, moving on, now you also need to create a pipeline stack. Now, this pipeline stack, you need to define your Git repository. In this case, I use GitHub. And I can also define the shell steps. And you can run the command, or you can also run like a security testing command here as well. And lastly, I need to add the stage. In this case, I have a staging environment, and I also have production. Now, once that you have this kind of stack and implement the CDK pipelines, once that you deploy it, you will have something like this, automatically. So this is really nice. Why? Because now you have IAC, you have your source code, and you have your pipelines together in AWS CDK. And what's really magical about this is that it's self-mutate. You can see this stage here is really important, the update pipeline. Why? Because what happens if you need to change from DynamoDB change to RDS? Basically, that you need to drop this DynamoDB, and then you need to create RDS or any other resources. But with update pipeline, it's self-mutating, which means that once that you commit your code into your repository, it's going to redeploy the architecture based on your CDK stacks and then deploy the codes that you have, which is really nice because we don't need to redo all this infrastructure and architecture again before we deploy our codes. And it's going to build the assets, and then it now deploy it to staging. But here's the thing. You can also implement continuous delivery by adding manual approval. So in real life, this is something that needs to be reviewed by the business side, the business organizations. You can also put these details and then like approve. So I can approve or reject. And if I click approve, it's going to start deploying into the production. Right, so that is the CDK pipelines. So what's next? I know this is kind of a bit compact and it's a lot of codes and CLI comments. The next thing that I believe after you adopt these three pillars are two things. The first one is observability and monitoring. And the second thing is the platform engineering. So you probably haven't heard about AWS Proton, but this has been helping our customers across global, because the way it works is that we divide the AWS Proton for two different personas. So platform engineers can create a template, and from the template, it can be used by the developers. So means that you can create a set of blueprints to help your developers to deploy your product, the applications. All right, so that's all that I have for today. Thank you so much. If you have any questions or you want to get my codes, you can reach me out after I go off the stage.